Imagine a Salesforce application where there are two types of actors, an administrator and a reviewer, and the application allows the admin to create a new review process specifying, for example, that all cases created in 2024 should be checked for correctly filled in information in some fields. After that, all records in this category are equally distributed between reviewers who have a special interface with only those records that are assigned to them. They check the field in information, leave their feedback, and Salesforce generates a document for this reviewed case. And after the review is completed, the administrator goes and compiles a single document with all individual documents from all reviewers and, let's say, fire the guy who constantly populates data incorrectly or demote him to a cleaner. It would be ironically though if it turns out to be an agent. Yeah. Anyway, hey everyone and welcome to this workshop on developing Salesforce Lightning application using LWC components. And I'll warn you right away that we are not gonna talk about how to create a LWC component, what it is, what it's for, absolutely boring. I don't know exactly what technologies this development will lead us to, but we will definitely talk about Lightning Web Security, third-party JavaScript libraries, dynamic component generation. I also want to touch on the topic of index database in your browser, probably together with the local and session storage, and much more. I will also try to skip the Apex part as much as I can, as the focus should and will be on Lightning Web Components. Our goal is to make this project, this application as comprehensive as possible and have some fun. And this fun has always been about design, you can't escape it. Sure, you could dive straight into coding with just a vague idea in your head and see where it takes you, but trust me, planning is the way to go. That's why we are kicking off this workshop with something many claim is extinct, but I say it's forever alive. UML, or Unified Modeling Language. I know, it's not a programming language, it's a modeling language. We're not saying that HTML is a programming language, right? I mean, someone says so, but usually after that they get so beaten up they have a hard time remembering their own name, so be careful here. So UML is a modeling language to get you to create diagrams for business or yourself in a structured way, rather than having a panic attack and adding all those pretty shapes that come to mind. And you know what? I'm already sick of those terms. Tell me honestly, how do you understand the term modeling language? That's what I'm talking about. So let's keep it simple. UML is a set of instructions. So we have the set of instructions of how diagrams should be created, and then we have specific diagrams such as activity diagram, sequence diagram, use case diagram, class diagram, object diagram, and so on. Each of which can have common things, but usually they are different from others. For example, use case diagram and class diagram are completely different and serve a different purpose. And accordingly, they have a different set of instructions of how they should be created. That is, UML is not about having one set of instructions for all diagrams. It is rather a set of instructions that is distributed between diagrams independently. And due to this difference, all diagrams are usually divided into two categories. One is behavioral and the second one is structural. Structural is about static and technical elements, such as the elements that make up your implementation and how they are connected, such as class, child class, parent class, batch, trigger, and so on. That is the structure. Behavioral is about a dynamic and interactive aspect of your system. That is, how different elements interact with each other, not necessarily at a structural level. Like the user clicks on a button, he's offered to enter his login and password to his bank account, he enters it, and we write off all the money. This is a behavioral diagram of what happened from a behavioral perspective. And the structural one would be how we implemented it and how it actually all happened behind the scenes. However, let's be honest, in practice you will mentally divide them into the other two categories, requirements and design. Under requirements you will classify use case and activity diagram, while all the others will fall under the design. This split is purely my representation of this, and essentially it means that these two diagrams here are used to represent requirements and don't say much about how it should be implemented. The other diagrams are already more technically precise and targeted. And anyway, we don't answer the question, what kind of diagram do we actually need? If you Google it, you will see a lot of those ratings of which diagrams are used more often, which are less often, and based on this you will make a decision which diagram to use. But this is a complete bullshit. My recommendation is to start with the requirements. For example, let's take a use case diagram for our application, where we indicate the actors who participate, that is the administrator, reviewer, and also this actor can be some third-party service for generating documents. After that we add this huge block in the center to kind of show that this is our application, and then we add how users interact with this app inside of this block. And then there is the stuff where some actions are included in other actions. Like here, for example, define review criteria is part of create review process. What we see here in no way tells us how it should be implemented, right? The use case diagram tells us what should be implemented. Then ask yourself two questions. What is the audience and what is the level of complexity? Then I would refer to the 4+1 architectural view model. I'll leave a link to a detailed article in the description, but in short, it presents your software as 4 viewpoints, namely logical, process, development, and physical. And another viewpoint at +1, which represents use cases and scenarios. This is already what we did by creating the use case diagram we just looked at. Then the first question here, what is the audience, gives the answer to which viewpoint you should focus on. If it is business stakeholders, a logical view is your thing to go, which represents the system structure useful for understanding objects, relationship, and business rules, and which might be accompanied by UML class diagram. If your implementation also requires a view of the application from the developer's perspective, which is most likely your case, you need a development viewpoint, which is accompanied by UML component or package diagram or class diagram in some cases. Then the complexity comes into play. For example, either integration or queuable jobs. If so, we should focus on the process view, which might be described by a sequence diagram. You don't need to cover all the viewpoints. For example, you probably won't need the physical view at all. And another thing is the number of diagrams. Everyone will always tell you about a need for 5 diagrams for this architectural model to be completed, which is kind of right, but my recommendation is to take some time and find a common ground. Very often one diagram can partially cover a few viewpoints, and this will be satisfactory in many cases, considering that we don't have the physical viewpoint in Salesforce, and in fact we have only 3+1. And even after this explanation, as you can see, we have a lot of ors and buts, and not because I'm trying to spend your time, but because there is no unique way to say that's what you need. I'll leave some links in the description, but in the meantime, we will take a deep breath, and in the next video we will start talking about Lightning Web Components. See you soon.